Hello and welcome to this hopefully short video on me trying to prove that the Ramsey number of 3, 4 is 9. So to be able to prove a Ramsey number we need to go from above and below. So I'm going to start off by looking at this lower bound to show that the Ramsey number 434 is going to be greater than or equal to 8. Now remember, this means there exists no blue triangle where all three nodes are connected by the same colour, and I'm going to choose blue for this condition, but it also means that there's no 4 nodes which are all connected in a red colour, so it's a square with a cross in the middle. Okay, and I can do this very simply with a counterexample. So my counterexample for 8 nodes is a colouring as is shown below. So if each node is connected to its opposite node from the look of this diagram, and adjacent nodes, then we're not going to yield a blue triangle if these colourings are blue. If I colour the remainder red, I hope you can see we don't end up with a red square. Okay, so pick any 3 red connections coming from a single node. There is not a complete square with those all 4 nodes connected. The final diagram would look something like that, but hopefully those 2 diagrams make it a bit clearer that neither of those 2 conditions are satisfied. Okay. Just a correction to that last one, it's not greater than or equal to 8, it's strictly greater than. So our counterexample of 8 shows that if I have 8 nodes, it does not guarantee either a blue triangle or a red square. Therefore, the true Ramsey number has to be strictly more than 8. It can't equal 8. So all that's left to do is to prove that it's less than or equal to 9, and then we can deduce that it must equal 9, as it has to be greater than 8. So I'm going to start off by thinking about a single node and its connections. Okay, so let's start off by thinking about, well, what if we had an equal split? What happens if we had 4 and 4? Okay, so if I have 4 nodes on the right hand side here, which are blue, remember I'm trying to prevent a blue triangle from happening, none of these nodes can be connected to each other in blue, otherwise you'll yield a blue triangle. I mean, just look at one of them. We've already got a blue triangle there, which means that all 4 of those nodes, okay, must be coloured red to prevent a blue triangle. Okay, so if I'm trying to come up with a counterexample, all 4 of these nodes must be coloured red, but then we've just yielded this red 4 connection. And this means that we can make the following conclusion. We can't have 4 or more blue connections from any one point. Okay, and this is going to be important for the future. Okay, so if we can't have more than 4 blue connections from any one point, well, what about, I'm not going to jump straight down to 3, but I'm going to say, well, what if there's 2 or fewer? Well, if we have 2 or fewer, that means we're going to have at least 1, 2, 3, 4, 5, 6 red connections. Okay, now because we know the Ramsey number, let's stick with blue. Because we know the Ramsey number for 3 is 6, I can now look at these 6 nodes in isolation. Okay, so remember, all of these are coming from a separate node, and all of those colourings are red. Okay, that's what I'm sort of saying. Now there might be 7 if there's even fewer even fewer blue connections, but there'll be at least 6. Okay, now because the Ramsey number for 3 is 6, this means that within this 6, we either have a blue triangle, and if we have a blue triangle, then I've already satisfied my first condition, yes, an R of 3, or we have a red triangle. Okay, something like this. If we have that, well then, because all of these nodes are connected to this external node in red, we're going to end up with a R4. Okay, this sort of 4 nodes all connected by the same condition. So that means that we can't have fewer, or fewer than 2. So all that's left to analyse is what happens if we have 5 red and 3 blue. Now, there are a lot of false proofs out online of this, and a lot of them are actually quite similar to this, where they say, well, if I've got 5 connections here, all of the same colour in that red, then I've got 6 nodes, and as the Ramsey number for 6 nodes is, for 6 nodes is the solution to R33, this means I'm going to end up with a red triangle. And so if this is a red triangle, this gives me that connection of 4, or it's going to give me a connection of 3 blue, and then I've satisfied my blue criteria. However, what this false proof fails to consider is, well, what happens if the R3 in red, for example, was this one? Okay. What we've actually got is only 5 nodes that we're playing around with, and if we think back to how we prove R33 equals 6, to show that 5 doesn't work, we come up with a counterexample, a bit like a pentagram symbol, okay, where our border is something like this, and the interior would, all of those other connections would be something like that. Okay, and that would not yield a blue 3 or a red 3. Now, for the sake of argument here, well, in fact, I'll come back to that in a second. So if we take those 5 nodes and colour them in this way, it's going to not give us anything. It might give us a red triangle here, for example, but it won't necessarily give us a red triangle amongst those other 5 nodes, and therefore yield an R4. Okay, so if I come from, let's just say I'm going to do a bigger diagram now, okay, and I've got all of these connections from it being red, so let's just colour them in, okay, and what I've done, I've taken those 5 nodes, and so that's going to be my border here, and therefore all of the interior connections I'm going to say are red, okay, like that. And hopefully you can see that I don't have a blue 3 or an R4. I have a lot of red triangles, so I've got a red triangle there. Yeah, I've also got a red triangle here, but I don't have that blue 4. And if I look at a connection of 3 coming out of there, they don't have an R4 either. Now, some of you might be saying, well, what if the border here was red and the interior was blue? I'm just going to show you that actually it wouldn't matter, because if we just shuffle these nodes around a little bit, we can always end up with a border that's blue. In fact, I'll just go over to GeoGebra here. So at the moment I've got a red border, but if I wanted to make it a blue border, okay, we can just move this over here. Will that work? There we are. Something along those lines. Okay, you can see I've now got a blue border. So by just shuffling around those nodes, it's the same diagram. Okay, so now I want us to focus on the other 3 nodes. Okay, so remember, these 3 were all coming from the central node with blue. Okay. Now, if all three of these connections are blue, then, as we sort of said before, none of the connections amongst them is allowed to be blue as well, because it will just yield a blue triangle. So if we're trying to come up with a counterexample, it's not going to work, which means all three of them must create an R3. Okay, that hasn't satisfied anything, but it's of note. Okay, so it's going to look something like that. And now what we need to do is look at how this group of 3 and this group of 5 connect to each other. And to do that, I'm not going to use this diagram, but I'm just going to sort of look at them side by side, like this. Okay. Now remember that all of the connections within this 5 are coloured red. I just haven't coloured them in for now because it would just get a bit too messy. And all of the connections in red from this first node would be red over to the left-hand side, and these 3 would be blue. Now what I'm going to consider are adjacent nodes in this diagram, and remember that the end nodes are also adjacent because they're in a loop. Now if any 2 of these nodes are connected to a single node in blue, then this is going to form an R3, okay, something that we don't want. So that means that at best we can only have 2 blue connections from each of these nodes on the right hand side. If I had a third, so even if I had one here, for example, I can't have that one, can't have that one, and I can't have that one. If we even shuffled it around, okay, something like this and this, well, that would still mean that I'd have an R3 with these 3 nodes, because these are also connected in blue. So one key thing from this is I can only have a maximum of 2 blues, and they cannot be adjacent. Now this also means, and again I'm just going to draw 2 different ones for the sake of this argument. Okay, it's all arbitrary, so it's just for illustrative purposes. It also means that I at least have one red node where there is a connection 2 above and 2 below. So this was the node that I chose. Okay, there's a connection 2 above and 2 below, and this will always be the case, because otherwise we've got 2 blue next to each other or 2 blue next to each other. So let's have a look at connections from the right hand side, and now we're going to start colouring them red. So I'm just going to colour it to an arbitrary one. I'm going to call it the middle one. Now this means that it's also going to be connected to these 2 nodes, because we cannot have 2 blue connections in a row. Okay, so I've just chosen the middle node arbitrarily. It could have been any of them, doesn't really matter. Let's say we've got these connections ready to go. Now if I now focus on another node and say it's connected to the middle one again, okay, so something like this, then again, because it's got to be connected to 2 either side of that one node, we'll end up with something like this. And this will result in, I've removed the last one because we've already got a red 4. Okay, if I just remove some of these other lines, hopefully you can see that we've got a red 4 there. So let's try and prevent that. Let's try and keep to this idea of creating a counterexample. Okay, so rather than choose the middle node to have its connection with, let's think about some of the other options. Well, again, if I pick this one here, it's got to be connected to 2 above and 2 below. So it's got to be connected to 2 above, which is going to be, this is 1 above, this is 2 above. But again, it's got to be connected to 2 below, which is this one. And again, we've resulted in this red 4 at the top. Okay, and a similar situation would happen if I chose arbitrarily to take my central point connection at the bottom. I'd have to connect to 2 above and that would create this red connection of 4 like that. Okay, so that leaves me 2 alternatives. Okay, let's put these colours back in. Actually, I will add these 2 in as well. Okay, so that leaves me either this option or this option. Now, due to symmetry, these again are pretty much, it doesn't matter which one I pick. So let's just choose the top one for now. Okay, and I know it's got to connect to the one 2 below and the one 2 above. So that would be 1 above, this would be the second one above. Okay, and now we need to have a look at our last node. Okay, now for the same reasons as this top one, it would create an R4 if it selected any of the middle, top or bottom ones with that first selection. Yeah, it's exactly the same working as why it didn't work out for this one. So let's say that let's not pick the middle, top or bottom, but now have to pick one of these 2. Now, if I pick the same one that my second choice node selected, well, I'll have exactly the same colouring as the second node. Okay, and let's just remove the middle connections. So I'd have exactly the same colouring as the middle node. Again, there might be more red connections, but I'd at least have these 3. And again, this would now create something like this. Yep, an R4. I mean, it would create several R4s because they would have exactly the same colorings. Because you could also have these 2 connected there. There's absolutely loads, but I'll just highlight one for you. There we are. Okay, so let's now choose our last option. Okay. So let's just put all the colorings back in. And I'll colour the original one back in. So let's project to this last node. Okay. So again, let's pick one 2 above and 2 below. So it's 1 below, 2 below. But again, we've got this connection with our second choice node. Okay, so if I remove other colorings, we can see that there's that R4 in place. So it's guaranteed, we are guaranteed an R4 regardless of what we select. Whichever node that third node picks as its central one, where it's got 2 above and 2 below, we're going to guarantee an R4. So we've shown that R of 3, 4 is guaranteed if we have at least 9 nodes. And as we've already shown that R3, 4 is greater than or equal to 8, we can conclude that R3, 4 equals 9. Sorry, not greater than or equal to 8, just greater than 8.